Hey guys, I actually didn't think I'd be posting any videos tonight because I've just been too busy with work all week. Still struggling a bit with the GE810. I got one nagging issue left. Didn't have time to start getting back on the Philco radio projects, and I've just started on the Dumont RA113. And then this box showed up. Now, I was expecting this because it was something I bought off of eBay, but I didn't think it would show up until Saturday or next week sometime. It's a piece of test equipment, something I've seen other guys use and really have good things to say about. However, they're very expensive. It's a Hewlett-Packard synthesized function generator. I'll just go get it right out there. I don't recall the exact number. I think it's a 3225B or something like that. They usually sell for hundreds of dollars, especially if they're working and calibrated like well over 500. So I set up a search on eBay just for ha-has. There's always a bunch for sale, but they're always well beyond what I'm willing to pay for one. However, then this one showed up from a seller that didn't seem to generally sell a whole lot of test equipment. But maybe he just came into some at an auction or something, I don't know, but he had 5 or 6 items, all of which were listed as working. However, few, if any, had any pictures of the items actually turned on and working, including this one. So it's pure gamble, but I think I only paid $75 for it. And I figured, if nothing else, it'll make an interesting video. Going to be all kinds of cool, interesting components inside of it. And even just for parts, I've seen these sell for a couple $100. So I figure, hey, how much can I lose on it? And you never know. It might work out of the box, or maybe just needs some minor repairs. Let's find out. Oops, I was off a little bit on the model. It's actually a 3336A. I'd set up a bunch of searches on eBay because Hewlett-Packard made a number of models that have similar functionality. And here are all the controls. So it's actually older than I realized. I think they introduced this model in 1980 or thereabouts. Now this particular example may have been made later than that. I imagine the production run went on for a few years. Won't know for sure, so I look on the back or pop it open and look for date codes on components. So what can this beast do? Well, it can do a lot, but in particular what I'm interested in doing is sweeping RF sine waves for aligning radios. This will go up to 21 megahertz, let's say 20.9 to be particular, and it goes way down 200 hertz or 10 hertz, maybe even lower than that. And it's digital. You can type in your frequency. That's what the synthesizer means. It's a digitally generated sine wave. So what they do is they update a digital to analog converter at a higher frequency than the output frequency. So maybe for one cycle of a sine wave they take a couple hundred points along that sine wave and they increment at a precise time interval the analog output voltage. If you do that fast enough, do a little filtering, you get a very clean sine wave out. And I imagine it can also do square wave and triangle wave and sawtooth waves and all kinds of fun stuff. So it can certainly do fixed frequency output. But what it can also do is sweep. So you can set your start frequency, stop frequency, or continuous is when you don't sweep. So imagine you do something along the lines of this, type it in, and this, type it in. And you can also do, I set the amplitude and set the phase. I think this can do amplitude, frequency, and phase modulation as well. Or at least, well, okay, for sure it can do amplitude and phase, and I guess frequency modulation is implied by doing a sweep, maybe? Or, I don't know. I'm sure it can do frequency modulation in some manner. So, I'm tempted to just plug it in and see what happens, but I think before I should do this, I should at least pop the top off and take a look at the back and make sure there isn't some glaring problem. I also noticed this was taped to the top of the cabinet. So on the back there might be some type of in-out that if you're not going to use an external device, this needs to be plugged into, because I think you could daisy chain several of these together, and if you're not, maybe you need to put this jumper in. Definite downside to this is that by modern standards, this thing is ridiculously large. Not incredibly heavy, maybe 25, 30 pounds, but size-wise, it's really, really deep. So it's not going to fit into my workshop very conveniently. For sure, it's not going to fit under the shelves I've got. So, assuming it does work, I think I'll have to keep it under the workbench and just pull it out as needed. Nowadays, all this functionality is on one little surface mount chip about yay big, and you would need to add some external controls and output amps, attenuators, and so on. But even so, it'd be much, much smaller than this. So what have we got? Standard computer type power cord, no problem. Got a fuse holder, good thing to have. And then here's all the various ins and outs. Reference out, external reference in. These maybe are the two you need to connect together. See, it's got option 004 and option 005 installed. I'll have to check out those. I imagine there are slots inside, like on a computer motherboard, and you can pop various options in there, and that's pretty standard for Hewlett-Packard equipment. Options might be like extended frequency range, extra output power, external interface interfaces, like this has a standard Hewlett-Packard interface bus. I think that's what HPIB stands for. And I imagine this is what you set it for, so you could hook up a bunch of these devices together, each with a unique ID, and control them all remotely. Alright, and you get external phase and amplitude modulation inputs on the back. Not the most convenient thing when the cabinet is 18 inches deep. You can't really reach around the back too easily to get those. And here's the fan, which is disintegrating foam. No big deal, I can replace that. I imagine this thing is going to be chock full of really high speed devices, maybe even emitter couple logic, so it probably gets pretty toasty in there. Well, it was calibrated by Lucent, so that would have been after the name change, I think in the 90s, something like that. Let's see, I got a serial number. What about a date? I don't see one, so I'll look inside. It's amazing how much you can learn from reading a manual for a few minutes. So first off, this only does sine waves, which is fine, that's all I wanted for. Two, the option 4 and option 5 are nice options to have. One is for a high accuracy frequency reference, and the other is for high accuracy attenuator. So those would look to be the two best upgrades you could possibly get. The others, as I thought, were different types of interface options. So a little jumper cable that came with it, I do believe, goes between these two. So this 10 megahertz oven output, that would be the high accuracy reference. The oven means there's literally a little electric oven that keeps the reference oscillator at an elevated temperature above the ambient temperature and at a constant temperature, because pretty much all solid-state electronics are affected by temperature. So one way to combat that is you keep them at a fixed temperature. So that's what that's all about. And then that would go into the external reference in. So, also I found out that this is from 1980. Was introduced, I believe, in the spring of 80. Initial list price, I think without these two options for the 3336A, $4,100. Or 33 years later, well, a few $100 on eBay. Alright, so how do you get this open? Well, I got carrying handles on either side. A piece of spring steel in here with a vinyl covering. Kind of convenient. So possibly I got to take those out. Or is there an easier way to do this? Yep, I'm sure there is. Probably just have to take that Phillips screw out, and this panel slides back. Again, I just want to make sure that there isn't something horribly wrong, like a loose piece of metal floating around inside that shorted something out. And they said to be very, or make sure there's adequate ventilation for sure. So it's supposed to be about 3 inches from the back and some space on either side. You gotta let air circulate or this thing will overheat. Here's how that jumper connects. Plastic's damaged on this side, but I don't think it'll cause any problems electrically. Alright, so I loosened up that Phillips screw, and yeah, indeed, this did slide back with a bit of effort, and I think the top is ready to come off. Now, I expect this is going to be pretty intense inside. I used to go to Hamfest a lot in the 80s and pick up quality test equipment from the 70s and early 80s, and the engineering back then was pretty impressive. Should be lots of gold-plated stuff, lots of high-frequency stuff, and lots of discrete components. It's actually not quite as intense or impressive as I was expecting, but nonetheless, very nicely made. I thought there might be more in terms of like RF modules and gold-plated stuff all over, but hey, as it is, still pretty cool. I bet this is all gold-plated underneath this conformal coating. I've scrapped out a number of Hewlett-Packard boards where they put a gold wash, not just on the edge connectors, they would put a gold wash over the entire copper-cladded areas and then put on the conformal coating. Conformal coating is just this greenish tinge stuff that they put over the entire board to seal it environmentally. So this must be the high-frequency synthesized fun stuff over here. And as usual, they put on all their proprietary part numbers for the most part, but so we had some LS logic up here and some S logic. This is all TTL, is different logic families. S is high speed and LS is low power. Yeah, I can't tell what most of this stuff is. But that's alright, I really mainly just hope this thing works. Super clean inside, not a speck of dust or corrosion or anything. Needs to be all the high frequency interconnects. Power supply, don't see any bulging caps, but if need be, looks like they wouldn't be very difficult to swap out. Some pretty hefty rectifier diodes. And here's our logic board, which looks to be all LS logic. Pretty much, unless house numbered stuff. There was a time when I knew pretty much every 74 series chip number, and I still remember quite a few. Like these are hex inverters. That's a dual flip-flop. Some of these are buffers. I think 27, that's a quad NOR gate, I think, or an OR gate maybe. 32, that might be an OR gate. I know an 04, it's inverter. 00, NAND gate. I think an 08 is AND gate. Alright, so that's that. And there'll probably be some type of custom microprocessor in the RAM for it, I imagine. So let's take the bottom panel off too, because there's got to be more to it than this. There's got to be the output attenuator, and I want to check out that crystal oven, so it's probably mounted below. In case any of you were wondering, yes, I do watch the EEV blog on a regular basis. In fact, that's the reason why I got one of these Fluke 27s after watching his great teardown of it and review of it. And I'm not going to try to compete with his teardowns. He does a much better job than I could ever do. Oh yeah, there's more goodies in there. Is that crystal oven from '88? So, as I thought, this unit is newer than 1980. The specs on this thing are kind of crazy. I forgot how many parts per million it is, but it's pretty darn accurate. It has about a 30-minute warm-up time, I think, or maybe 75 minutes. So the power switch in this actually has several modes. There's off and there's on, but there's also standby, and standby keeps power going to this to keep this oven warm. Alright, more goodies. This might be the attenuator inside this box. Looks like there might be machined aluminum cavities in there. I suppose I could loosen these screws up and take a look. I'm not crazy about accidentally breaking anything, though, as you can imagine. That's probably the output amplifier. For instance, it says amp on it. Amp flatness adjustment. Can put out a fairly decent amount of power. Oh, actually, this might be the attenuator in here, because that goes right to the output jacks. It's weird, they have 3 output jacks. Different frequency ranges and different impedances, you use one of these 3 jacks. I'm used to somewhat newer devices like this, where this thing can go like 1 megahertz to 1 gigahertz with a single output and attenuator. So I'm not quite sure why they had to split this down into 3 outputs. I'm sure they had their reason. Also, in the looking at the manual and the product announcement article, I think this was meant for like the telecommunications industry, which is why it doesn't go very high up in frequency, but it's very, very accurate. I think it was more meant for the audible range and maybe into like modem kind of stuff. So up until like 19,200 and higher bauds. Alright, well, I do not see any serious problems. Or actually, I don't see any problems. What am I saying? So one thing I haven't checked yet is the fuse. And I'll try tentatively loosening up one of these screws. I'm not going to take that box open, but this one looks like it might be fairly easy. Those little screws are on there way too tight. I'm not going to mess with it. So I went on and checked the fuse. It's good. I dug up a power cord. I've got it plugged in. So, let's give this a try. Dope. Huh. Oscillator fail. External. Well, it's good and bad. I mean, one, it powers up. And oscillator fail? Well... maybe I don't have that connector on right. And even if it is bad, possibly I could get a replacement module, but also, who's to say I have to use it? For one, I think I can disconnect this, and it might fall back to using the lower resolution internal oscillator, or I can feed in my own. Takes a 10 megahertz, 1 or 10 megahertz reference, and I think it's just 5 volt TTL logic. So I'm going to give this a try without that cable, see what happens. No, same problem. Imagine you can't do much with these controls as long as that is off. Alright, well, maybe this is bad, so I'll dig up a BNC patch cord and give that a try. Nope, still no luck, so I'm going to hook up a scope to that external reference output and see if there's anything actually coming out of it. Yeah, actually there is, which is kind of bad, because that might mean that the oscillator's fine, it's the input that's bad. That could be very difficult to fix. Let's see what we for frequency? It should be 10 megahertz. 10 megahertz. So, mixed news. Well, I'm going to read through the manual a bit more and see if maybe I don't have some of the right mode settings or something. I was curious too, now that I've disconnected it. It's an external reference when I had to do connected together, but now that I've disconnected it, it went off. So that's what I was thinking, if you didn't have that option connected, it would fall back to using the the internal low-res oscillator, and that's bad too because it still means that there's an issue here. Grr. Alright, well, I didn't find anything obvious in the user's manual that I was doing wrong, and there was no section on error codes. I probably need to get the service manual for that, which I have not found a copy of yet. Also did a quick Google search on this model and the error message OS fail and found nothing, so I will proceed as best I can. So next what I'm going to do is fire this up with the cover off and check the voltages, because they are conveniently labeled on the power supply. So we got, it's like +5, -15, -15, +5, and then it might be plus or -15, I can't quite tell. So let's make sure all those are good. And then I'll make sure the cables are all seated down, wiggle things when they ship can become dislodged. And I'll check underneath that external reference in. There's continuity between the center pin and wherever it's going to inside. Okay, I checked the voltages. +5 and ±15 dead on. Also went online and found all sorts of manuals. The owner's manual, the operator manual, the service manual, got schematics, got a partial parts list. What I don't have is a troubleshooting guide, so I couldn't find anywhere in those manuals to indicate what oscillator failure might mean. So I went back to inspecting this, and I noticed this cable's a little bit loose, snug that, check this. And then I came to this guy. Well, that sure doesn't look right. So, maybe it's as simple as that. There we go. Boy, that was really out of there. I don't know how that could have come out just in shipping or whatever. I mean, you really have to yank up on that. Alright, so I'll flip this around and give it another try. Alright, keep your fingers crossed. Oh yeah, much better, I think. Looks better than failure to me. Oh yeah, cool. Now let's get a scope on this and see if I'm actually getting some output. Now this is with the internal oscillator. I've not hooked up that little cable back to using the highly stable reference, but even so. Nice. Oh yeah, that's a nice clean sine wave. So I got the thing exactly on 10, so there we go, 10 megahertz. I'm going to try turning that frequency knob. Well, not surprisingly, it changes so little. Turning, all the way down to 9.9 something. So not the most practical way to change frequencies. Let's see what these do. Oh, I see. You can select which digit you're going to change with the wheel. So let's go all the way over here. Alright, so. Now this is something else I was curious about. Is it says on the front that the frequency output is 20.9, right? However, there's a signal on the back, they call it like an annunciator, that if you dial in greater than 20.9, that'll flag a signal. It goes 21 to 60, so that got me thinking, why would they bother with that if this thing is limited to 20.9 megahertz? And that got me thinking, well, maybe you can go higher than 20.9 They just don't guarantee the accuracy of it. Now, why do I care about that? Because of all these vintage TVs I work on with their 22, 23, 24 megahertz IF strips. Whenever I'm doing alignments, I need to dial in like 21.5 for a sound carrier or 27.5 for a trap. Now, luckily, somebody figured out how to modify a VA62 so you could dial in a frequency, because this normally is limited to a range of 35 to 50, I believe. Yeah, 35 to 50, because this was designed for 44 megahertz IFs. Somebody hacked the ROM for this and gave me a copy to let me get a lower frequencies. However, it's not really technically an RF generator. It doesn't have a good output attenuator. The sine wave looks a little bit lumpy on certain frequencies, especially the further you get off of the 35 to 50 range. So I always wanted something that could dial in a really specific, accurate frequency for doing IF alignments and for marker generation. So, that's awesome. I'll probably also be able to sweep TV IF frequencies too. So let's see, how high can I go with this? 31, 40, 50 megahertz. That looks pretty darn clean sine wave to me. Oh, wait a minute, that's kilohertz, not megahertz. I see, this thing went down to kilohertz. How do you get back into the megahertz range? Does it jump over automatically? Nope. Or was I looking at 10 kilohertz all this time? I thought I was looking at megahertz. That could be. I'm not used to something having this. Here we go. Now we're up to 20 megahertz. I'm not used to something having this many decimal points of accuracy. So that is 20.8419462 megahertz. My scope's got nuts now. Still awfully clean. It says 20.8 something. Trigger's not perfect on it. Now let's see if I can actually go above 21. No. Oh well. Alright, forget all that nonsense I just said. Forget about using this for TVs, but that's alright. I really got it for radio work anyways. I'd be curious to know if somebody ever hacked this. I mean, I don't see any particular reason why you can't go. I guess there is one other possibility, which is to type in the frequency. Let's see, how do you spell? You should do this. So, 20.0000000. Enter. Don't. 5.0000000. Push it again, maybe. Nope, that didn't do anything. You think there'd be a set or something? Surprised I can't toggle that on and off either. Somebody out there is probably laughing at me right now. I guess I should read the manual again. Alright, well. Let's see if I can get to sweep. Oh yeah. It's sweeping alright. Huh. So, I do believe, at first blush that this is fully functional. I still need to check putting that jumper in to check the high accuracy frequency, but for the work I'm doing, even the what they call a low accuracy oscillator is still way beyond anything that I need. So that's cool. So that's why I take chances on eBay. Now, I don't always win. Sure, I got lucky with this, got lucky with my Suncor CR70 and my Wavetech sweep generators, but this guy needs some work. I still got to get back to this. The inductance, impedance, inductor mode stuff doesn't work at all. Capacitor stuff needs some work. I did order up some new caps for this, and I've got a low capacitance cable I want to make a probe with, so I'll be getting back to this. You may recall I also picked up a Suncor TC162 tube tester. Well, you probably haven't seen me use it in any videos, and that's because there's something wrong with it, which I think maybe is shorted winding on the transformer, because the power transformer hums and it gets really warm. So I don't think that I've got some kind of magic touch and everything that I purchased works. This guy was dead when I got it, and I had to replace nearly 100 tantalum capacitors, which took for friggin' ever and cost a few bucks, but it does work now. Just took a lot of work. But hey, you know, if you got a few bucks and you feel like gambling, by all means go for it. The stuff was incredibly well made. I found date codes in this. This was made in 1988, so it's, what, 25 years old. Seems to work just fine. So you'll see when I get around to aligning a radio, some of the cool stuff you can do with this. I've seen some screenshots guys have posted on the Antique Radio forum when they use this for aligning radios, and it's awesome. You've seen me before try to align radios using sweep generators like that old RCA WR50B or something like that, which kind of worked, but this will work so much better. So you get a nice crisp IF, you can put a marker in there, should work really, really well. Okay, I kind of figured out how to enter in the frequency. Hit frequency, type in the numbers, then hit hertz. And I think for amplitude, you type it in and hit dBm, and for phase, type it in and hit degrees. So right now I got 580 kilocycles or kilohertz dialed in, and I got my radio tuned to about that. And I got the amplitude cranked up pretty good, and I just took some BNC, that's a BNC cable that outputs to an alligator clip, and I put it by my radio. So the radio should have picked this up. And then you can hear, as I turn this around, so more fun with radios. So what are we actually hearing? Well, what we're hearing is the difference between like the local oscillator in there and this oscillator. You may have heard of people using radio dials to calibrate things like frequency counters. Well, what you do is if you got a radio that you know is very accurate and set the dial to like say 580, if this is also exactly 580, both of them are perfectly at the right frequency, you hear no tone. As one or the other deviates, you hear the difference between the two. So what we're hearing is the difference in frequency between the two. Okay, you can stop posting your comments. I realized I made a mistake. What I meant to say is what you hear out of the radio is not the difference between the radio's local oscillator and your RF generator. It's the difference between your radio's local oscillator plus minus the radio's IF frequency and the RF generator. And I believe it's usually minus the IF. So, for example, assuming your radio has an IF frequency of 455 kilohertz, and you want to listen to AM 1000, your local oscillator is running at 1455 kilohertz. Something else is you can indeed go up to 60 megahertz with this. However, there's a catch. So, for example, I'll type in 30,000,000, so 30 megahertz. As soon as I type it in, that light goes on, and there's nothing coming out of these jacks now. There's a jack in the back that's labeled 21 to 60. Fortunately, what comes out of that is not a nice clean sine wave that you can adjust the amplitude on. It's actually a square wave, and it's 12 volts peak to peak, fixed. You cannot adjust the amplitude. I know it doesn't look too much like a square wave. That's because we're working at high frequencies here, and the higher you go, the harder it is to get a nice sharp clean square wave. So for example, we'll drop it down to 22. Looking a little more like a square wave, but if I go all the way up to 60, now part of this is also a limitation of my scope. Only has 100 megahertz bandwidth, so when you start looking at 60 megahertz and 100 megahertz scope, you're not getting all the subtleties that are there. Now, this is totally unsuitable for injecting into, say, a TV's IF stage. It's way too strong a signal, and it's not a sine wave, so there's a lot of harmonics mixed in there. However, what I might be able to use it for is a marker generator. So for example, this guy has a BNC jack in the back for an external marker, and it can be pretty much any amplitude, well, a wide range of amplitudes and waveforms, and this thing will clean it up. I think it's got a limiter in there, and it just picks out the frequency. It doesn't care about the irregularities in the waveform. Yeah, it's a little bit overkill to use something this big beast for a marker generator, but if I need a really accurate marker for something, it's a possibility. Certainly more accurate than using something like this analog RF generator for markers. I've got it now running with that crystal oven frequency generator, and it seems to be working okay with this as well, so let's try doing this little test again. The radio. Yep. So, no doubt I'll be having lots more fun with this, and you'll be seeing more of it in future videos, but right now I think I got to read the manual a little bit more and figure out exactly how to use this beast. Hope you enjoyed this look at a Hewlett-Packard 3336A synthesizer level generator. Originally from 1980, but this one was made in '88.